Alright, here we go. Let's review our functions packet to prepare for a test. We're going to start out with number 9. And we're going to take our function and just find f of n squared. Now these problems, all you have to do is take what's inside the parentheses here and use the substitution property and substitute it in for the variable. And that's it. Like, really, that's how easy that one is. You just substitute in. Now, if you have one like number 12, where you're plugging in a binomial and you're cubing it, don't forget that you square it and then you use the distributive property, combining like terms. But 1 through 12, you just substitute in. Alright, now we're looking at number 15. We're given two functions, g of n and h of n. And we're to find g plus h of n. So g plus h. Since I'm adding, there's not really any need for the parentheses, are there? If I were subtracting, which I'm about to do in number 20, what would happen to all these signs in the second one? They would change. But since I'm adding, we're just going to simply combine like terms, and that's going to be it right there. Number 20, I have a function f, I have a function g, and we're to find the difference function. So we have f minus g. We'll just have to be careful. Watch our signs, because this will be a negative n squared and this would be a positive 5n. And we need to put this in descending order to make it standard form. And so that will be a negative n squared, and a 1n and a 5n is 6n, and 2 plus 5 is 7. No, sorry. I'm sorry. I thought this was just a 5, y'all. I put these two together. This is just a plus 2. Sorry. Sometimes my eyes play tricks on me. Alright, 21. This is a multiplication problem. So I'm finding the product function. Okay, so we're doing multiplication. That's not an open circle like a composition function. It's multiplication. And so we'll have f multiplied by g. So what method, you mentioned this earlier, what method do we multiply binomials with? FOIL. So first, outer, inner, and then okay. So, and then last, negative 3 times 4. So this would be negative 4x squared. 4x and 12x is 16x, and then minus 12. Okay, questions on any of those? Add, subtract, multiply, divide. Divide's next. When you divide, you have to remember that there's a restriction. You can't divide by 0. So let's look at number 26. We have g of n, which is n squared plus n. And we have f of n, which is n minus 1. And we're to find g of f. of n. So it's just what it says. You take g and you divide by f. Now if I could factor this out and get an n or n plus 1 on the bottom, I would do that. But since they do not cancel each other out, then I can just leave it like this. I have to set a restriction because I cannot divide by 0. So I set this equal to 0 to find out what it cannot be, and n cannot be 1 because 1 minus 1 is 0. So here is my answer with my restriction though. Alright, 28 g of t is equal to t minus 2, and h of t is t squared plus 4t. And the problem asks us to find g of h of t. So we take t minus 2, divide that by t squared plus 4t. And again, if I could factor out a t, but I would get t plus 4, not t plus minus 2. And so there's no point in doing that. If I could, I would. If I could reduce that, I sure would. But I'm going to leave it like this. Now, what would make t squared plus 4t 0? Well, how you solve a quadratic equation? Try factoring. If you want to be crazy, you could, do the quadratic formula. That won't work here. But I think factoring in this case is easier. You take your two factors, you set them, I messed up right here. If I divided those by t, which I bring out here, I'd be left with t plus 4. Alright, so I'll set my t plus 4 equal to 0, and t would be negative 4. So here's my two restrictions. T cannot equal 0 and t cannot equal negative 4, because if you'll think about it, if you'll plug them in on the bottom here, that both of them would become a 0, and that can't happen. So there's my restrictions with my answer right here on 28. Any questions? When I factored this out, if you have a greatest common factor that contains a variable, you also set it equal to 0. See, there's got to be two answers because this is quadratic. And so I set t equal to 0 and t plus 4 equal to 0. There has to be two restrictions. Think about it. If I plugged in 0 up here, I'd get 0. If I plugged in negative 4 and squared it, I'd get 16. Plus 4 times negative 4 would be negative 16. That'd give me 0 down here also. Alright, now let's look at composition functions with number 33. H of n is 3n plus 1, and g of n is 2n minus 1. And we're asked to find hog h of g of n. So let's determine what we're going to plug in where. We're going to plug this. This really means, I kind of prefer this notation. This really means that I'm going to take g and plug it into h. So we'll have 3. We'll take the n out. We'll substitute in a 2n minus 1. And then we'll add 1. So that would be 6n minus 3 plus 1, which simplifies to 6n minus 2. And that's hog. Questions on that? Nobody say anything? Alright, I'm going to find the composition function in this first way and then plug in a over 2. So that means to find the composition function, we're going to take G and plug it into F. Because fog is really the same thing as this. And so 2 times a cubed plus 5a is 2a cubed plus 10a. There's the composition function. And then, if I plug in a over 2, and simplify that, I end up with 2 times a to the third and 2 to the third, and then half of 10 will be 5a. And 2/8 reduces to 1/4, and so that's my final answer. So I found the composition function, and then right here I plugged in. Okay, the other way that you're talking about doing it is to find f of g of a over 2. And we'll get the same final answer. So into g, we're going to plug in a over 2. So that would be a over 2 to the third power plus 5 times a over 2. That would give me a to the third over 8 plus 5a over 2. Now we'll take this amount and plug it into F. And F is 2 times a, so we'll take the a out, we'll plug all this in. And we end up with 2, we're going to 8 4 times. And 2, we're going to 2 2 times. And get the same final answer. So here we just plugged in. We didn't even find the composition function. So I'll let you decide which one you like better. Alright, and then somebody said do 42, which is very, very, very much the same. So why don't you guys see if you can do it, and then I'll work behind you. Composite function. Alright, we're going to plug F into G. So this is 2 times 4x minus 4 minus 2. Bless you. So 8x minus 8 minus 2 would be 8x minus 10, and that's the new G of F. And we're supposed to plug in x over 2 into that. And so half of 8 would be 4, so that's 4x minus 10. Now if you could do it the other way, I'm just giving you options here. You're going to find f of x over 2. And half of 4 is 2. And then we're going to take that and plug it into G. And so that would be 2. And then 2x minus 4 in the place of x minus 2. That's 4x minus 8 minus 2 gives us the 4x minus 10. Cross multiply. We're just solving for y here, so we need to add 15. And then divide by 8. And that is the inverse. You could split those, that's just this new name. You could split this up into 5/8 x plus 15/8 if you wanted to.
So, like, say we just have 1 equals 5x plus 15 over 8.
See, that can be confusing because now you got two functions equal to y. So one's f and one's f inverse, because that's what you were finding.